Now let's look at, pardon me, exercise number 13. We're supposed to find a general antiderivative of this g of theta equals cos theta minus 5 sine theta. So again, when we see that general antiderivative, then we know we need to put a plus c on the end of our answer. And again, it's typical standard notation that if the original function is given to us with a lowercase letter, then we usually write the antiderivative with a capital. So we're trying to figure out what function could I write down so that if I were to take its derivative, I would get cos theta minus 5 sine theta. So I don't want to take the derivative of what was given. I want to go in the opposite direction and find the antiderivative that has as its derivative cos theta minus 5 sine theta. So the first question I need to ask is, what function has cos theta as its derivative? So we know, since the derivative of sine theta is cos theta, then that means sine theta is an antiderivative of cos theta. So for this first term, I can put in sine theta as the antiderivative. Okay, and then I need to know whose derivative would be negative 5 sine theta. And again, the 5 is a constant multiple, so I can sort of carry that along. But I know the derivative of cos theta is negative sine theta. So that means that cos theta is an antiderivative of negative sine theta. So carrying the constant multiple along, I can write as my second term here 5 cos theta. And always a good idea, especially when you're first learning how to do this, is to check your answer. And the way you can check one of these antiderivatives is to take the derivative of the antiderivative. Whoa, what? If you take the derivative of the antiderivative, you should get back where you started. So if I take the derivative of sine theta, I get cos theta. If I take the derivative of 5 cos theta, I get negative 5 sine theta, and that is, in fact, the original function. So I know I did it correctly. Now, number 24 is a little bit different. First of all, notice the notation. They gave us f prime, and they told us that f of 1 equals 6, and they want us to find little f. So note to self, when they give you the notation little f prime and they ask you to find little f, you're still finding an antiderivative. So whose derivative is 8x cubed? So this is, again, a polynomial. F prime is a polynomial. 8x cubed is a power function. So we can carry along constant multiples, raise x to one higher power, and divide by that higher power. So we're doing exactly the opposite of what we would do if we were trying to find the derivative. With the next term, my constant 12 can get carried along. I can raise x to one higher power and divide by that higher power. And again, remember the constant 3 we can write as 3x to the 0. So I'm going to carry my constant multiple 3 along. I'm going to raise x to one higher power and divide by that higher power. Now in this case, you don't see it asking for the general antiderivative. In fact, they gave us the fact that f of 1 is 6. So what we're going to do is start with the constant, but then we're going to find out what that constant is. So note to self, since f of 1 equals 6 is given, we will solve for c and find a specific, or you'll sometimes see it referred to as a particular, antiderivative. Okay, so my little f, let me just do a little simplifying here. 4 goes into 8 twice, so 2x to the 4th would be the first term. 2 goes into 12 6 times, so I can write the second term as 6x squared and then plus 3x plus c. And then f of 1 equals 6. So, buttons up your undershirt, if I let x be 1 in this equation, and then I set the whole thing equal to 6, I can solve for c. So I have 2 plus 6 plus 3 plus c has to be 6. C must be 6 minus these 3, add up to 11. So 6 minus 11 is negative 5. So apparently, my little f function is 2x to the 4th plus 6x squared plus 3x minus 5. That's the antiderivative, and it is a specific antiderivative whose value when x is 1 is equal to 6. And again, you could check your answer by finding f prime, the derivative of the antiderivative. And if you take the derivative, this is a nice simple polynomial, you get 8x cubed plus 12x plus 3. And of course, the derivative of the added constant negative 5 or subtracted constant 5, either way you look at it is fine. But the derivative of that constant term is 0. And so again, I get back what I started with in terms of f prime, so I know I did it correctly.